Okay, chapter 4 is going to be probably the most boring for you guys, but luckily if you've taken any type of biology, anatomy, most of it should seem pretty familiar, but it's very important to know the way that our nervous system works when we're talking about drugs, because obviously that's how we feel the effects. That's how we end up with tolerance and withdrawal symptoms and um, all of those things. It's all because of our nervous system. So if you don't understand how the nervous system works, it's hard to understand how the drugs are able to create the effect that they're creating, or how to understand how to treat them, and why sometimes we use different medicines to try to slowly back people off of drugs, or different things like that. So one of the first things it talks about is homeostasis. Hopefully that term sounds familiar to you guys. If it doesn't, think of like a home thermostat and how it regulates the temperature, where if you set your thermostat for 75 degrees and it is winter and it drops below the 75 degrees, your heater automatically kicks on to get it back to that 75 degrees. Same thing happens in the summer. If it gets too warm compared to what you've set your thermostat at, air conditioner kicks on, brings it back to that set temperature. Our body is very much like that, and it does it with a lot of different things. Our own body temperature, hunger, our blood pressure, all these things. We have kind of a certain level that our body tries to stay in, and it's called homeostasis. So the same thing is going on in our brain, with levels of chemicals and all of these different things. The first big component that they talk about is the neuron. Hopefully you have an understanding of a neuron. You guys are going to have to do a little assignment on that. But basically make sure you know a couple things. One, your action potentials that travel through your neurons are always going to be going in one direction, and they're all or nothing. You can't, once your neuron fires, it fires. You can't stop it from firing or bring it back. It's gonna, the information is gonna travel from your dendrites. That's where it's gonna come into your neuron, and then it's gonna flow through your axon to your axon terminals, and then it's gonna release that message. While it's inside the neuron, it's an electrical message. Once it gets to the terminals, you're going to release a chemical, and the chemical is going to go in the synapse, which is that space from one neuron to another. And then it's going to be a chemical message that travels from the axon terminals of one into the dendrites of another. That's where the issues with drugs comes into play, because a lot of these drugs are very similar to our neurotransmitters, and a lot of times that's what's happening. It's causing us to release more of a certain chemical, less of a certain chemical. It's causing us to reuptake or take back more of that chemical out of the space than normal, and they relate to the natural chemicals that we have in our body. You'll see a lot of them as you go through your chapters. The molecule itself of a lot of drugs are very similar to the molecules of a lot of natural neurotransmitters that we have, like dopamine and serotonin and norepinephrine and all of those fun things. So make sure you just kind of know those parts. Again, know the way that it flows. Know that it's all or none. You can't take it back once your neuron fires. It gets pretty in-depth into the actual action. A couple of things you want to, like, this terminology. If it's talking about it being permeable, that means it's going to be able to go through a certain boundary. We talk a lot about the blood-brain barrier and what can travel through that, because certain drugs are going to be able to go through and certain drugs aren't going to be able to go through. And you're going to have things that are partially permeable, like some things can get through. You're going to have certain substances that or boundaries that might be non-permeable. So it mentions that a little bit. Talks about how the action potential happens. Basically, it has to do with the polarization of your neuron and it being either hyperpolarized or depolarized. And again, a lot of that just has to do with the amount of sodium, potassium, and how they're related across the borders. You're not going to have to get too specific into that. Like I said, I really want you to just know, the basics of how the action potential works. Know that once your neuron fires, it fires. It talks a little bit about, it gives you some different, like it talks about multiple sclerosis being something that there's a problem with the myelin sheath, and the myelin sheath is the part that's around, it's like a fatty substance that's around your neuron or your axon part of your neuron, and it makes the messages travel faster. So part of the problem with multiple sclerosis is there's damage to that myelin sheath. So that's something interesting and important to know if you know anybody that has that, or you're going into any type of medical field. It also talks about the difference between the somatic nervous system and the autonomic nervous system. Very important to know. Autonomic, just like it sounds, it's automatic. It happens automatically. We don't control it. We don't think about when we need to breathe. We don't think about when we need to make our heart beat. Those things happen. Our blood pressure, our heartbeat, our breathing, all these things that are natural, and we don't even think about it. The somatic is going to be the stuff we control ourselves. So that's your muscle movement and things like that. There are different, again, neurotransmitters that they talk about. I would have a general idea of what some of these things are. Acetylcholine, okay, that's in your parasympathetic. And so the parasympathetic and the sympathetic are branches of your autonomic. And basically, if you've ever heard of fight or flight, that's kind of a good example of what your parasympathetic versus your sympathetic branches do. Your sympathetic is going to basically prepare you for fight or flight. If you get into a fight or flight situation, which really could be anything stressful, we teach in psychology, fight or flight doesn't have to mean you're running into a bear and you're deciding, I'm going to run away from the bear, I'm going to fight the bear. Or I'm running into a person with a gun and I'm either going to fight them or run away. It could be any day stress. Your body actually responds with fight or flight. If you're running late, and that stresses you out, your body is physically responding to that stressor in a fight or flight manner. So basically, your sympathetic system is going to speed everything up, your heart rate, your blood pressure, your breathing, to prepare you for whatever it is your body needs to do. The parasympathetic is going to be what calms you back down and kind of brings you back into that homeostasis. When we talk about the basic functions, everything is going to speed up with your sympathetic except for digestion. Digestion is actually going to slow down because think about it. If you're about to run away or get in a big fight, the last thing you want to think about is being hungry or food or having to go to the bathroom. So that'll actually slow down. And then when you get into your parasympathetic and all of your other things are slowing back down, like your heart rate and your blood pressure to normal, your digestion will speed back up to normal to get you back to homeostasis. So there's a lot of different things in there, but just know the basics. And like I said, fight or flight is a good example to remember. And just remember that sympathetic is what speeds you up and gets you ready, and parasympathetic is what brings you back to that sense of homeostasis. There is a chart on page 81, and it talks about all those different what's happening during each of those. But like I said, know the basics, your breathing, your heart rate. Again, we're going to look at some of the major neurotransmitters. You should know dopamine. You should know serotonin, acetylcholine, epinephrine, norepinephrine. Those are all going to be neurotransmitters that you're going to see quite a bit of, especially dopamine, especially serotonin. And then as far as the different parts in the brain, again, you really just kind of need to know some basics, especially that are going to be involved in, when we're talking about hormones and chemicals and things like that. So your hypothalamus is going to be a big part of that. But they also show you some different, like we already talked about multiple sclerosis. They talk about Alzheimer's, and how it destroys parts of your brain, and Parkinson's and how that destroys, different parts of your brain. So it's good to know some of those different things too, because like I said, if you're in any type of medical field, or if you're even interested in looking at why are we now studying the use of marijuana to help with Parkinson's patients? Or is, maybe one of these drugs could help with Alzheimer's. And you can't study those things without knowing what part of the brains are being affected, what chemicals are already there, what neurotransmitters are happening, what's the process, and how could these other drugs that we're going to put into our body help or hurt, depending on the situation. But there's a lot of research out there now, like I said, in regards to marijuana and Parkinson's. So maybe that's something you guys are going to look up for one of your, you might want to use for one of your discussion points or one of your weekly questions. That might be something that you could fit into that discussion. Let's see. Again, you can take a look at some of the molecules and see, what kind of looks similar in regards to certain drugs with certain neurotransmitters that we already have. There's a good picture on page 86 that shows you where some of the different major areas of the brain are. Those are important to know. But like I said, if you've had biology or anatomy and physiology, or even psychology class, we teach this. So if you've had any of those classes, these are pretty basic areas that hopefully you already have a good understanding. Let's see. Around page 91, it talks a little bit about brain imaging, so you have an understanding of how we look at some of these things. They talk in here about your MRI, your functional MRI. You have what's called a PET scan. You can do a CAT scan. The MRI is pretty common. You don't see the PET scan quite as much. But you can see, the thing about that is a lot of times they'll be able to show you different areas of the brain, usually in colorful pictures where you can see certain things are being activated here that aren't being activated here, whether that's from a drug, whether that's from a disease. So when we talk about drugs, obviously, we're going to look at those different areas and see, okay, if we take this certain drug, what area is being activated or what area is being damaged after use of a certain drug. So are certain areas in the brain receiving damage from use of different drugs, from overuse of different drugs? Does it only happen after using it so many times? Is it something that's pretty immediate? So all those things are cool ways that we can look at the different neurological things that are happening. So that pretty much gives you the basics of the nervous system. So again, if you have any questions, let me know, but make sure you know those basics.